Hi, everybody. This is a Q&A session tonight, so every other week is lab or Q&A. If you have any questions about any of the course content, please drop a line in the chat so I know. And if I get any questions, I'll go over them. Otherwise, I'm just going to let the music play for a bit, and if nobody has any questions, then we'll call it a night. So, enjoy these Stardew Valley tunes, and hope to hear from you in a little bit. Let me see if I can find that. I'm sitting here just... I actually loaded up Stardew Valley to see how far I had gotten. I'd gotten really far, apparently. I don't remember how to play this, so I'm hitting buttons trying to go through a menu and figure out what's going on. Let's see here. So, hi, Maya. Maya wants to say hi. Wait, no, come back. Maya. Hi. Say hi. 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 She's upset because I had 5 minutes to cuddle with the cat, so right before class. So I went on the bed, and then they were very happy, and then I had to get up. So, analysis. Oh, there isn't a part B for this one. Did you mean part? Oh, I'm sorry. It's part B, question 7. Okay. Ah, what is happening? Oh, I probably moused over the trash can or something. It says, suppose that another experiment was carried out with the same NaOH, but the concentration of the HCl was instead 0.1500. So, what that question wants you to do, so let's go to the previewer here. Let's see here if I can capture... I can apparently capture Stardew Valley, which is kind of funny. Like, boop. That's how far I got. I was doing pretty good. But we don't want to capture that. We want to capture this. Oh, that's not what I meant to do. Sorry. There we go. That's what I want. Okay, so what you need to do in the experiment is at some point you will determine... Oh, it's not writing. Hold on. Oh, there we go. It was just delayed. Okay. So at some point in the experiment, you're going to determine the HCl concentration. And the way that you do that is you use the volume of sodium hydroxide, and then you figure out how many moles there are in there. Oh, great. Now Maya's jumped up on a chair and is meowing closer to me. Yes, hi. Hi, yes. So you get this number from the experiment, and then that's from like parts 1 through 6. And then what part 7 says, well, what if this was... Is this the concentration? I can't read it on my screen. So it says, if this was 0.1500 molar, instead of whatever you got, then... Then what happens to this? And so it's saying, based on your answer from the previous experiment that you did in parts 1 or questions 1 through 6, now consider, what if this was 0.1500 instead and you did everything the same? What would happen to your volume of NaOH? Would you use more of it or less of it? And so you need to, first of all, have an answer for the molarity of HCl from the actual experiment. Maya, please go away. Okay, she's finally gone. Then you need to know, okay, is my answer higher or lower than 0.1500? And then work backward through the calculation and see what happens. Because if you can go one direction, going in the other direction should be pretty straightforward. Especially if all the other numbers are the same. Oh, geez, I know why I don't know how to play Stardew Valley. I use a controller. I should probably just grab that. I'm like, what key does what? I don't remember. Did that answer your question? I hope so. Yeah, don't use M1V1 equals M2V2 in this lab because this is not a dilution. So you're doing a titration, so you can't do... There's no formula for titrations. You have to do the stoichiometry. And the way to do the stoichiometry is shown up here. You can't see the whole thing, so I gotta do this. So I give you this sample problem, sort of sample problem, to figure out how to figure out the number of moles of sodium hydroxide that were used for, okay, here's what concentration you have and how much was used. So here's how many moles there are. Here's the stoichiometry. And then you can figure out the molarity here. So don't use M1V1 equals M2V2. If you do use it, you actually get the same answer in this case. However, that's only because right here... I can't highlight both of these, can I? I can't. Right here, this is 1 to 1. If this was any other number than 1s here, M1V1 equals M2V2 would not work, because what that formula is trying to do is just moles equals moles, right? And like, oh yeah, we showed it, moles equals moles. But that's only true because both the coefficients in the equation are 1. Where is the balanced equation anyway? There it is, right there. So yeah, follow these directions to get to the end. This shows you exactly what to do. Any other questions? Is the quiz due tonight? No, it's due tomorrow. I mean, I think so anyway. It should be due tomorrow, right? I didn't change the note on the screen, so I assumed that that was correct, because nobody corrected me. Yeah, due February 2nd. Available till February 3rd. So it's actually, it closes on the end of Wednesday. Yeah, labs due on the same time. When calculating percent error, is a negative percentage possible? Yeah, so what the sign tells you for percent... Oh, let me get rid of this again. Boop. What the sign of percent error tells you, so here's the formula. So, experimental minus true over true. What did I just do? I just clicked on something in the background. Times 100%. And so what happens here is that if experimental is less than true, then you get a negative percent error. And if experimental is larger than true, you get a positive percent error. And that makes sense, right? Because you're just looking at this value right here. A smaller number minus a bigger number is going to be a negative number, yeah? Now, if you think of your results as like a number line, and where this is the true answer, which would be 0% error, what your percent error basically does is the bigger the number is, the further you are away. So this would be 5% error, whereas this might be negative 2% error, something like that. The number just tells you how far away you are, so the magnitude of your error. And then I'm going to add a little plus here. And the sign just tells you which direction the error is. So a negative 2% error would be closer to the correct answer than a positive 5% error. A negative percent error just means, oh, my answer was less than the correct answer. And a positive means my answer is larger than the correct answer. So since you get some information out of the sign, I say keep the sign. I know some instructors just give you the same formula, but they stick absolute value bars out here. I think that that's kind of silly because you're just erasing data that could be useful. Like if you did a bunch of experimental trials and you got 4% error on average, but the percent errors that went in there were like negative 10, negative 8, and then positive 20 or something like that. Losing that minus could tell you something. Or it could cover up something, I guess I could say. How do you discern the most precise set of measurements from a couple of data sets? So if you're given multiple data sets, you want to look for the ones that have the lowest difference between the numbers. So something like... So what I would do, if I wanted to look at precision, I would look at the two that are furthest apart, and I would compare them, and I would say, okay, the difference between these is about... whatever this is, 2.9. And so this, compared to the average, which the average is about 38, so this is almost like an 8 or 9% deviation. Whereas for a different set of data, like this, if I took the biggest and the smallest here, now the difference is just that, which compared to the average would be a much smaller deviation. This is less than 1%. Actually, this would be about 1%. And so this would be much more precise, and this would be not as precise. Generally speaking, you just tell by looking at the numbers and saying, oh, there's a large spread on these. That's not very precise. Yeah, you just look at the... They're not really outliers because we count them in the average. But the points that are just furthest apart, those are the two that you should look at. Because going over here to the precise data, to say that this is an outlier and this is an outlier, when, like, this one is okay, seems kind of weird. Generally speaking, if you have data that is an outlier, you discard it before you do the precision analysis. You always have to justify that, though. So, like, if you trash a trial without justification, such as, oh, a systematic error occurred, I didn't tear the balance of this trial, then you're basically just fabricating data and cherry picking. So that's no good. In academia, that's a common thing that people do, is like they'll do 30 trials and get like a 90% correlation, but they need a 95% correlation to publish, so they'll get rid of 4 outliers and say, oh, we only did 26 trials, and hey, our data is great. And like that's academic dishonesty. So we don't want to trash any data unless there's a really good reason to. Like, oh, I did the experiment just totally wrong. But yeah, people totally do that. I mean, yeah, you could just totally keep testing. Can I, like, control this? There we go. I don't even remember what my farm looks like. Let's go outside. Oh, it's winter! I don't even remember what I was doing. I clearly didn't build very much. Yeah, I haven't done this yet. There's my cat. I don't know why my cat's out in the snow, but my cat is out in the snow. Hazel, get inside. This is back before, so I had a cat named Hazel. Before Maya and Kresnik. Hazel was like 22 when she passed away. And so anytime there was a pet in a game, I would name it after Hazel. I adopted Hazel when she was like 17 from somebody. I don't remember how to play this game. Like, I would have to sit down and play this from scratch and just, like, start completely over. Which is fine. Like, I like doing that. How do I exit the game here? There we go. Are we gonna finish Chapter 6 tomorrow? Yeah, if we don't finish Chapter 6, I'd be surprised. What do we have left in Chapter 6? Let me open the slides real quick. That's 131. That's not what I want. 161 slides. Chapter 6. What did we do? Oh, we're like almost done with molarity anyway, so we did that. Yeah, I'm just doing mass percentage, volume percentage, parts per million, parts per billion, it looks like. We don't do anything Chapter 7. We used to, because we were asked by the people who did 162, like, hey, can you do Chapter 7 balancing chemical equations for us? And we're like, sure. And then 161 ended up being way too long, and 162 was a little shorter, so we don't do that anymore. So you don't have to worry about balancing chemical equations. I'm not going to test you on that. But we will start Chapter 3 tomorrow. Chapter 3 is kind of the miserable chapter. Like, we're going to get, like, 20 slides into Chapter 3, and then it's going to be like, oh god, I don't know what's going on. Ah! Like, it's that bad. Okay, last call for questions, since I'm basically just goofing around here. I could just chat with you guys about Stardew Valley in the Discord. But while I have the stream up, like... Is there anything I can answer while this is up? Let me know. I guess I could just turn this back on. So, let's see here. Let's see here. There we go. I'm not playing it, I went back to the soundtrack on YouTube, so I'm gonna shut up for a bit and go get some more water, and if I see that there's any more questions, I'll answer them. Otherwise, we'll just turn off the stream. So, the charges go by columns in the periodic table. That's right. So, you do kind of have to remember that from Chem 140, that chlorine, when it forms an ion, is always -1. That question, unfortunately, is sort of a legacy question. Like, when we taught this class with a different textbook years ago, we had talked about ions and, like, how to form ions and ionic compounds in Chapter 2 or something. And so, yeah, knowing that chlorine is -1, figure out what the charge of copper is based on your formula, and then tell me if it's consistent with it being 1 or 2. Okay, I'll be right back. I'll just put this on the screen for now. So if you have an answer for your molarity, I can tell you if you're close. I can calculate it really quickly. Let's see here. What's the molarity? 0.2. Okay. Trying to do it in my head. What did I do wrong here? Point 0.2 times the volume. Okay, yeah, I have an answer. I think you have a mistake in that number. If I did this right in my head. Make sure that when you're doing, you're using the volume and the molarity of NaOH, make sure you turn the volume into liters. When you multiply by 0.2000 moles per liter. I'm talking over the music, I just realized. Sorry, let me just turn that off. Oh, did you use 0.5? Yeah, for this problem, it's a different amount. It's 0.5 in the example. I'm all screwed up here. Like, I should be on this screen when I'm talking. Yeah, do 0.2 instead. Actually, let me see here real quick. So your answer times 0.2 over 0.5. Yeah, you get pretty much the right answer. So you're doing it correctly, I believe. I think Maya got sick of waiting for me. She's like, "You're coming back to the bedroom so we can just sit on the bed and I can be pet forever." I'm trying to speak as if I was Maya. Just lie on the bed and pet the cats forever. That's apparently what I do. But okay. Yeah, I think that you have the right answer. I don't know which trial that was for. I just did trial 1. But what you had for 0.5 is close to what I got for 0.2. Close all tabs. Yes, that's fine. Oops, that's not what I meant to do. All right, last call for questions. Let me know. Otherwise, Maya's going to come right back in and start harassing me again. If you're a cat owner, you know. Your cat basically dictates how you live your life. I'm going to go back here real quick just so I can fix this. Class will reconvene in 10 minutes. There, we'll just fix that. Let's see here. I need this window. What am I logging into? There. Oh, I've already logged into this. Let's see here. Quiz 2. I don't want to edit it. I set it for 45 minutes, right? Yeah, I did. Okay. Let's see here. I think that the quiz is set to the right amount of time. Make sure that you have all your notes handy. You know what you're looking for if you are using your notes. Better yet, don't rely on your notes. That's probably the best strategy. It seems like people are doing okay, though. Are all the same types of questions on the test? Yes. So when I make your exam, I have a bunch of pools that I pull questions from. That I've basically programmed like 60,000 questions in the canvas. I could show you this actually. Well, I can't show you that. That's student grades. I don't want to do that. That would be a FERPA violation. So let's do this. So when I make a test, you get some behind the scenes action here. This is what it looks like for me. And so if I go here, so these are all the questions that I choose from, and each of these is a pool, and each of these pools has a bunch of questions. You can see that that's just 121. I have 7 pages of this, so like I get to the 161 stuff, and it's just like pages and pages and pages of this stuff. And so like if I just picked like say 140, like here's a 140 pool. And so like each pool has X number of questions in it, which you can't see because I had to expand them. You like name this acid, and so like it just picks from these because I had to program it to do this, and it takes forever. But when I go make the exams, I put questions in the pool, and oops, we'll just not show that. I take questions and pull them from the pool, and then it assigns them to you randomly. But I do have similar pools for exams and quizzes. So sometimes questions show up a second time, but the odds of you getting the exact same questions on the exam are not very high because, as you saw in that one pool that I showed you, there's like 8 questions in there, right? So, and I only assign you like 2 of those, maybe, or 1 usually. So the odds of you getting that and then on the exam getting the same one from that pool, very small, because it'd be like 1 out of 64, right? To get any question once and then, well, I guess no, it'd be 1 out of, no, it'd be 1 out of 64. No, it wouldn't be. It would be 1 out of 8, because there are 8 possible ways to do that as 64. Did the question come right in my notes? Yeah, I literally have the PDF open when I'm writing these quizzes. Just to remind me of like, hey, what are the topics? What should I test you on? I have the PDF open. I do refer back to the worksheets or the homework, depending on what class it is. So I think for 161, you have the OpenStax text, which has like all the homework problems. So I give you that. I look in there for exercises. Some exercises are really hard for me to make up. Like, it's very difficult to make an empirical formula problem because I can't just pick random numbers, right? But I bet I could find an analogy for every problem in the textbook, other than the ones that I have specific questions that I cover that aren't necessarily in the book. So, like, I go into mass spec into a lot of detail. So the book might not have that as much, but the details I will test you on are from the slides. You should round to the number of sig figs the question asks you to. And as long as you do that, you're pretty much guaranteed that you will fall into the error region for the problem. So like what I do is I compute the correct answer, or I have it do that for me because it's a formula. I program the formula. I could show you that too, I guess. So let me see preview. Let me find. There is supposed to be. Where is it? Oh, this is 140. That's why. I'm looking. I should look at 161. Is this it? Yeah, here we go. So here's everyone's favorite problem. So this is the problem. Let me just do this real quick. So you've all seen this problem before with hey, there's this orc that is he found lots of money, and how many monies is away? And so what I have to do is I have to program in a formula and then generate possible solutions. So, if you got 32,608, here's your answer. But importantly, what I do is that I tell you to tell me the answer to this however many sig figs. And then what I do is I go calculate the answer and I report the result, and then I give you a small leeway so that if you are within that much on that sig fig, you'll get the right answer. So, like, if you rounded the correct answer to 3 sig figs, no matter where your rounding errors are, you're not going to be off by more than 0.03, which would just be plus or minus 3 in the last digit. So I could change this number. I could do this. Now you put in any answer and it's correct. But if you only needed 2 sig figs, I would do that, for example, because then the 10th place would be the second sig fig. And so on. So like that's my methodology, and it works out pretty good. So you don't really have to worry about rounding too much. Just making sure that you get the correct answer. When you're asked for a number on the quiz, only ever enter the number. I think if you try and put in the units, it will tell you, please enter only a number, or something like that, and it won't let you. Sig figs on the lab sheet, you have to actually apply the sig figs rules. So, I only tell you on Canvas because Canvas doesn't know what sig figs are. So when I have it spit out a number, if you get the sig figs wrong, you will just get the wrong answer, and there's no partial credit on Canvas. Like, you either get 0 or 2 for a 2-point question. But on the lab, I give you partial credit. So if you get the right answer, I can look at it really quickly and say, oh, you intended to get 14,500, but you wrote 14,557. So then I'll flag it yellow and say sig figs, but Canvas can't do that. So on the lab sheet, follow the rules for sig figs for doing addition, subtraction, multiplication, division, depending on what problem you're working on. And then report your answer to the correct number of sig figs based on that. Yep, should be good. Most of those problems, they're all 4. Like, every number I give you is 4, so your answer's probably going to be 4. Multiple choice questions with multiple answers, yeah, you get partial credit. You get points for marking correct answers, and you lose points for marking incorrect. It's scored in such a way that if you checked every option, you would get 0. So if there were like 3 correct answers and 2 incorrect answers, and it was worth 3 points, each correct answer would be worth 1, but each wrong answer would be worth negative 1.5. And you can't get a negative score. So, like, if you only check the wrong answers, you just get 0. That's how I think Canvas does it. Because otherwise, you would just check all the answers and get 2 out of 3 or something like that, right? If I didn't know the answer, that's what I would do. Is I would just check all the right answer or check all the wrong answers too. Kind of like the old SAT thing where people would fill in every bubble and the scanner only checked for the correct answer, so you'd get every answer right. That's a legend. I'm pretty sure that never happened, but I could see it happening. This has become more like gossip hour, which is fine. I don't care. On my quizzes online, I actually have it shuffle all the answers, so I don't know what the answers will be in terms of A, B, C, D. I just tell it this is the right answer, and then it moves it wherever, which is kind of obnoxious because I can only really do that for all the problems. And so then you'll get questions like choose from this drop-down list from the answers. And the drop-down list might be like 1, 2, 3, 4, 5, 6, 7, except it shuffles that, so it's like 3, 7, 4, 5, 1, 6, 2. And it's like, don't do that. Canvas, why? So if you get a list that looks like it's been shuffled and it really shouldn't have, that's Canvas being stupid. Not much I can do about that, unfortunately. Like, what Canvas can do is good, but compared to, like, me writing a quiz, like, you saw my test bank. It took me hundreds of hours to write those questions. Easily hundreds of hours. I could write a quiz for class in 30 minutes. And I wouldn't even have to make a test bank because I just write one quiz and I just do that every quarter. I'd make a new quiz. Like, well, it's time to write a quiz. I'll sit down for 30 minutes and do it. But I can't do that on Canvas. I can't spend 100 hours every quarter. Considering that we only interact with each other for about 40 to 60 hours, spending more time on that than I actually lecture, to me is ridiculous. I can do nuclear physics. I can't do nuclear engineering. Nuclear chemistry is super easy. Here, I'll show you the secret to nuclear chemistry. This is basically all you need to know about nuclear chemistry. There you go. A neutron is the same as a proton and an electron combined together. And that's actually true. So, if a neutron decays, it will turn into a proton, and then this gets ejected. So this is beta radiation. Hold on just a second. Do. Oh, I didn't mean to do that. That's okay. There we go. Now you are publicly shamed, whoever you are. So that's one thing that happens in nuclear chemistry. There's other particles too. So we already talked about an alpha particle, which is this. And then a gamma ray is just light. What other fun things can happen? So basically what this is doing is it's saying, like, okay, if I have, I don't know, this, and one of its neutrons turns into a proton, so this would increase, but the mass remains the same. And so something like that would happen. So that's nuclear chemistry. That's really, like, that's really it, to be honest. Like, you can condense it down to, like, where'd my pen go? So, like, everything on the bottom here So this, if I draw a line here, so Z on this side must equal Z on this side. And you might go, well, wait a second. 8 doesn't equal 9. And in reality, well, how we write an electron is we do this. An electron has a -1 charge. It has the opposite charge of a proton, so I put a -1 down there. And it has no mass, essentially, so we do that. And then up here, A on this side has to equal A on this side. And so as long as that works out, then you have a valid nuclear equation. There you go. That's nuclear chemistry. That's really all there is to it. Case in point, I took an entire class on nuclear chemistry in college, and I slept through probably the last 5 weeks of it, because it was at 11:30 a.m., and that's really early for me when you're a senior. So I just didn't go. I didn't take any of the quizzes, because I slept through them. I showed up for the final. I was like, I don't really care. I've already graduated. I took the final. I got an A+. I got like 90 out of 105, and the mean was 49. And the instructor was amazed, and the TA who was working in my laboratory at the time that I was also working was furious, because he was like, I'm going to look forward to failing this guy, and I get the highest score on the exam by far, and the teacher's like, I'm giving this guy an A. He knows his chemistry. So nuclear chemistry is not that hard. I think if you are interested in it and you want to go into it, you could do it. Yeah, I was just reading the text. Like, I found it really interesting. But I didn't want to go to the lecture because it was, one, it was early, 11:30, air quotes. And two, I wasn't really getting anything out of the lecture, so I was just reading the text. And then I went to the review session, and I was like, wow, this isn't very hard. Like, I understand all of this. Okay, I'll take the exam. I go in on the day of the final, and my friend is there too. He was taking the class too. He's like, wow, I thought you dropped the class. I was like, no, I just didn't want to show up anymore. I wasn't getting anything out of it. And I took the final. I got the highest score by like 50. Which I agree is absurd. Like, don't count on that. I actually know very little about neutrinos other than they are like the lightest particle. They are extremely tiny. They used to be defined as having 0 mass at all. But they have slight amounts of mass. They are a particle that comes out of nuclear chemistry. Like, they're a fragment. So, like, on what I'm writing on here for nuclear chemistry is pretty much all you need to know. But nuclear physics goes into much more detail. So, like, there are muons and tauons and things like that. There's quarks that we have to consider. And I know very little about that because nuclear chemistry didn't cover that. That's nuclear physics. But yeah, so there's like a giant thing that captures neutrinos. I thought it was under the Antarctic. I actually have no idea where this is, but it's this giant, like, empty room, and if a neutrino passes through it and actually hits one of the things, like, it creates fluorescence somehow. I forget what exactly, like, triggers that, but it lights up, and then there's like 60 million lamps or sensors on the walls that see it, and so they detect any signal that comes through. And the reason that they need something this ginormous and empty is because neutrinos are so small that the probability that they bonk into something is like, I don't know, it's astronomically small. It could be heavy water. I don't know how you get that much heavy water to the Arctic. And also keep it water. Anyway, that's a conversation for another time. We can talk about that in Discord, so. If there are any more questions about the class, let me know. So, yeah. We'll just go over here. We'll turn on the music because that's what I do at the end here. We'll resume class tomorrow with Chapter 6, and we're going to start doing Chapter 3 soon. Get ready for that.